Let's practice predicting the splitting patterns for the different protons in, we have 8 molecules on this worksheet. We're going to be using the n+1 rule. The n+1 rule helps us predict the splitting patterns. I'll explain that as we get into the rule. Splitting takes place between protons that are within 3 bonds of each other, and because of this whole 3-bond concept, it is a little bit easier to think about the splitting, analyze the splitting patterns if we actually draw the hydrogen atoms onto these line structures. It makes it easier for us to count how far away the hydrogens are from each other. So if we start with this set of 3 hydrogens right here, and we want to see how far away from any other hydrogen are they, we'll just use this hydrogen right here as our kind of our starting point. This hydrogen is 1, 2, 3, 4, 5 bonds away from another hydrogen. That means that it is too far away from any other hydrogen to be split by the other hydrogens. There are 0 hydrogen atoms that are within 3 bonds. Using the n+1 rule, 0 plus 1, this is going to be split into, it's not split at all. This is just going to be a singlet. This N right here represents the number of hydrogen atoms that are within 3 bonds. Here's our second set of equivalent protons. We already know that these guys are too far away from the hydrogens on the left to be split by them, but are they close enough to these hydrogens over here? So we'll use this guy as our counter. 1, 2, 3. This is within 3 bonds. So this guy and also its buddy are within 3 bonds of these hydrogens right here. So these protons are within 3 bonds of 1, 2, 3 other protons. 3 plus 1 is 4, which means that this is going to be split, this peak is going to be split into a quartet. We'll have 4 peaks. These protons are also within 3 bonds. They are 1, 2, 3 bonds away from 2 hydrogen. So this is 2 plus 1 split into 3. That is a triplet. Looks like that. Let's practice again on our next one with the chlorides. So we'll draw the hydrogens on, makes it easier for us to count. One thing that is going to come up with this particular problem, protons that are magnetically or that are chemically equivalent to each other will not split each other. So in this molecule, all of the 9 protons in this molecule, they are all exactly the same due to the plane of symmetry through the middle of the molecule. There's only one type of proton in this molecule, and when there's only one type, they have no neighbors. There are no different hydrogens that are within 3 bonds of them. So this is all 9 of these are just going to be a single peak, a singlet. Let's come down here to this one and let's draw these hydrogens in to make it easier for us to count, to see where they are. So we have these hydrogens right here, which are equivalent to these hydrogens right here. So these 4 are all exactly the same. And let's use this hydrogen right here kind of as our counter. It is 1, 2, 3 bonds away from this guy. It is not 3 bonds away from these guys over here though. 1, 2, 3, 4, 5, too far away. So this hydrogen is 3 bonds away from 2, same as its buddy, 3 bonds away from 2. What about these guys over here? They are also 1, 2, 3 bonds away from 2. Different set of 2, but nonetheless, for all 4 of these equivalent hydrogens, any one of these hydrogens is within 3 bonds of 2. So all of these guys, I'm just going to kind of draw a circle around them. They are within 3 bonds of 2. 2 plus 1 is 3, so they are going to be a triplet. Now I understand that that's pretty tricky. You might have to think about that one a little bit. So these 4 down here, they are also equivalent to each other. They are 1, 2, 3 bonds away from 2, or 1, 2, 3 bonds away from 2. So same kind of a situation. These guys are also 2 plus 1 is 3, a triplet. Let's draw the hydrogens over here on this molecule, and once we get them all drawn, we will start On the left-hand side, these 3 hydrogens are equivalent, and they are 1, 2, 3 bonds away from 2. So these are 2 plus 1 is 3. That's a triplet. And these 2 are 1, 2, 3 bonds away from 1, 2, 3. 3 plus 1 is 4. That is a quartet. This hydrogen right here, well, actually, let's not do that one yet. These hydrogens here are the same as these hydrogens here, and they are 1, 2, 3 bonds away from this little guy. So I'm trying to think of the best way to draw these. All 6 of these hydrogens are equivalent. They're going to make one peak together, and they are 3 bonds away from just 1. 1 plus 1 is 2. That's a doublet. Now this little guy right here is 1, 2, 3 bonds away from 1, 2, 3, 4, 5, 6. 6 unique hydrogen. So this guy right here is split 6 plus 1 is a 7. Septet. Sometimes I like to call that a seventet. Let's actually do this one next. We'll draw the hydrogens onto this. So starting on the very left-hand side, these 3 hydrogens right here, 1, 2, 3, 4, they're too far away to be split by anything. So these are 0 plus 1, a singlet. These hydrogen right here are 1, 2, 3, 4, too far away from this. 1, 2, 3, 4, too far away from that OH. So these ones are also going to be a singlet. These hydrogens are equivalent to each other. They are close enough to the OH. 1, 2, oh no, they're not. 1, 2, 3, 4. They're too far away. So these guys will also be 0 plus 1 is 1, a singlet, and the OH also a singlet. Although I did want to add, and we'll scroll back up to the top here, hydrogens that are on alcohols that are part of the OH, also hydrogens that are on carboxylic acids, and hydrogens at the end of an aldehyde. So that would be this hydrogen at the end of an aldehyde right here. They are falling on and off molecules all of the time. And because they're coming on and off molecules all the time, they are not coupled to the other protons, which means that they don't split or cause splitting, even if they're close enough to do so. So for this molecule, we've got 3 hydrogens on each carbon on the end, and these 6 hydrogens are all equivalent to each other. Then we've got these 4 hydrogens right here that are equivalent to each other, and then these 2 down here on the bottom. Starting with these 3 hydrogen, which are equivalent to these 3 hydrogen right here, this hydrogen, we'll use this guy first, is 1, 2, 3 bonds away from 2. And these hydrogens also are 1, 2, 3 bonds away from 2. So for all of these hydrogens, they are 3 bonds away from 2. 2 plus 1 is 3. These are going to be a triplet. Same over here. 2 plus 1 is 3. These will be a triplet. Let's do the ones that are in the middle. These guys right here are 1, 2, 3 bonds away from 1, 2, 3, 4. 4 plus 1 is 5. That's a pentet, 5-tet. These guys right here are near a lot of protons. They are 3 bonds away from the ones on the end, 1, 2, 3. So these are 3 bonds away from these 3. And they're also 3 bonds away from these guys right here. So they're 3 bonds away from a total of 5. 5 plus 1 is 6, which is a sextet. But one of the things that's kind of tricky is that if a set of protons are within 3 bonds from 2 different types of protons, so these guys are within 3 bonds of this set and then also this set, which is different. If they are within 3 bonds of 2 different types of protons, even though we can predict the splitting is going to be 6, a sextet, it's not necessarily going to look pretty. It's not necessarily going to look nice. So it might not be a pretty sextet. It might end up being like a messy, what we call a multiplet, due to something that we refer to as complex splitting, being split by 2 different types of protons. Let's do this example next. In this molecule, we've got 3 hydrogens out here on the end, and then we have 9 equivalent hydrogens out here as well. These 3 hydrogen are 1, 2, 3, 4, 5 bonds away. So these guys they have 0 hydrogens near them, so they are going to be a singlet. All 9 of these hydrogens are equivalent to each other, and they are 1, 2, 3, 4, 5 bonds away. So all of these will also be a singlet. Remember that they cannot be split by their equivalent hydrogen. So if these hydrogen are equivalent to these hydrogen, that means they can't be splitting each other. They can only be split by hydrogens that are different. Here's our last molecule. We have 2 hydrogens here, 2 hydrogens here, 1 here, 1 here, and then we have 6 total on these 2 methyl groups. We'll start with this guy right here. This is 1, 2, 3, 4 bonds, too far away to this guy. 1, 2, 3 bonds, 1, 2, 3 bonds, close enough to this guy. So this one right here is going to be a 1 + 1, a doublet. This one is close enough to this one. What about the methyls? 1, 2, 3, 4, too far away. So this guy is also 1 + 1 is a doublet. Going back up to the top, this one is 1, 2, 3 bonds away from 2. So this is 2 + 1 is 3, a triplet. And we'll look at these guys next. We know that they're close enough up here, but what about these ones down here? 1, 2, 3, 4, too far away. So these are 2 + 1 is 3. And these guys down here, we'll just double check one more time. They're too far away from everything. 1, 2, 3, 4. 1, 2, 3, 4, too far away. So all of these are 0 + 1 is a singlet.